So, welcome, Charlie. So, what I want to say here is that the test is not logged. Like I can log the test here, but I'm not locking the test. So the test is not logged here. So the students can join the test whenever they want. So you just need to go to kahoot.it and the pin is 87677. You just put that value and you can join the test during the test also. Okay, dear students, so we have gathered the 5 students. So that is a request from me. Please don't leave the test. Go for all the questions, okay? Because you are just 5 students. Okay, then we are going to start the test now. There we go. So the first question on your screen is this. Yes. Students, those who are watching the test, please join the test at kahoot.it and the code is also given in the chat 87677. There are total 10 questions that we will do in this test and every question is given 1.5 minutes. So nearly 15 minutes test. The question is, although very easy, it won't be needing 1.5. Okay, so the time is up. Let's see. The correct answer is C and only 2 students were able to answer it correctly. So this is not correct. There are 3 students, those who are going for the option D, by the way. Let me tell you what is this. The internal energy of the real gas is. So we are going to compare the real gas and the ideal gas. Of course, it is not going to be 0. Equal to the intermolecular potential energy, equal to the total kinetic energy of the particle, equal to the sum of intermolecular potential energy and the total kinetic energy of the particle. So the answer should be D. Equal to the total kinetic energy of the particles. Well, according to me, the answer is D, but I'm really sorry. I don't know why. The answer here is taken as C. I think that's a mistake, probably, with this question paper. Okay, no problem. Sorry for that. Let me see. In the next question, I don't know if I did some mistake with the Kahoot or something. Okay, let's go for the second question. Sorry for the mistake, by the way. Okay, let's go for the question number 2. Yes, we will. Now, I hope the answers are not wrong in this. Okay, people, let's see what is the correct answer. Yes, the correct answer is A. I have read the question. Probably the question number 1 was wrongly created in Kahoot. That will be my mistake. But here 3 students have answered it correctly. So let us try to see what is there in this question, dear students. Now, so this is the Wien's displacement law curve that is shown here. and this curve is at 600 Kelvin. So what is going to happen at 450? So number one, it will be going lower, like the intensity is 1, so the intensity will be reducing now, and it will also be shifting towards the right hand side. So that is going to happen. So this happens only in the option A. That is why A option is correct. If the temperature will be more, the peak value will be going towards left hand side, and that even it will be moving higher. So that is why A answer is absolutely correct. Moving to the next thing. Okay, what is the scoreboard now? Probably, I'm very sorry for the question number 1, but let's move to the next question. Question number 3 on your screen now. Yes, all the best. It's a very good question, and you would be getting similar kind of questions in this topic, luminosity and apparent brightness. It's a very important topic. Okay, dear students, let's see who is winning. Very good. 3 students have given it correctly. The answer is B, and some of the students are wrong. So let me see how to do this. So overall, I'm just giving you an idea. Like the luminosity is like luminosity divided by the area is given as the apparent brightness. Like I hope you understand. Like this is the sun, and some light is coming out. So the luminosity is the power of the sun, and at this planet, what is the brightness? Brightness means intensity, and the formula is given by L divided by 4 pi d square. Now in this question, the brightness is not changing, it is the same. So I can just say that luminosity of the sun 4 pi d square. Now for the other star, the 4 times more luminosity, so the luminosity is 4 times, and you have to talk about this d dash distance. So the other factors, they are cancelled. So when d will go there, so clearly d dash is coming out to be 2d from the calculation. So I'm not going to do the complete calculation here. So the answer will be B. This is how we do this question. Okay, let's see what is the scoreboard now. Well, Dinesh has clearly moved to the top 1. Very good student. So let us see what is going to happen in the next question now. Question number 4 out of the total 10 questions on your screen. Okay, this is the same question repeated again. Okay, people, so now everybody know that the answer is D. Quickly, we are moving to the next question here. Yeah, you people can just do it, and I would be skipping this question. Yeah, so everybody is correct now. Very good. Now moving next. Question number 5. Sorry for all the mistakes in this test. It has never happened earlier. I don't know why it happened in this test. All the best for this question. It's a very good question. Very good question. It was asked in examples from IB Physics. Okay, moving to the answer screen now. Well, only one student has answered this question correctly. Now, this question indeed is it's very tricky. I would say it's very tricky, and it was in the examples. But the important thing is that it was asked for SL, not even for HL. But still, it is a very good question. Now, window one is made up of single glass pan of the thickness D. What it says is like, let's say this is the thickness D. There is one glass pan here, and window 2 is made up of two glass pans of the thickness D each. So there are these two glass pans here, but there is this air inside, like this is the air inside here, this is the air, and this is the glass, this is another glass here. Yeah, both windows have the same surface area, separate air masses, temperatures, with the same temperature difference. So the thermal energy transferred in the first window is Q, and what it will be in the second case. So it will be, of course, like it will be lesser than Q by 2. Why? Because like you can see that there are two windows, first of all, two glasses, and overall the thickness becomes double, so thereby reducing the total number of like total heat which is able to move, able to pass through it. So your heat energy which was transferred earlier was Q, but now of course it is Q by 2. But here there is a gap between the two glasses. This is air, so this air is also creating one layer which the heat has to pass, and air is also taken as bad conductor of heat, and so of course it is also creating some problems, so it will be lesser than Q by 2. Now that will be the correct answer. Okay students, so this is how we do it. Next question is, and anonymous is the student who is the only student who attempted it correctly. Moving to the next question now. Question number 8 is also a very good question. It was again from the example. All the best. Okay, very good. Two students have attempted this question correctly. Very good. Let us move to next question now. Anonymous is leading the chart now. All the best. Question number 7 on your screen. Okay, so one student was correct in this question. Let us discuss this question now. A cylindrical metal rod has a temperature difference between its ends and is in steady state. Steady state means that the amount of the heat which is entering from this point is getting out of the other side, and there is no loss and they are all equal. The rate of energy transfer along the rod is written as P. No energy is transferred. This energy is not transferred. From here, there are no energy losses. The rod is changed from one made up of the same material, but with double the length and double the diameter. The temperature difference is half. The rate of the energy transfer in the rod will be. My dear students, in this clearly we are going to use the Fourier's law, and this is Ka divided by L into delta T, and accordingly we can see. Now in the first case the power is P, this is K, and area is written as A, length will be taken as L, and this is delta T. But in the second case, what is the new power we have to find? K is the same because we are using the same material. Area, the diameter is double, it means that area is double, pi r square. So if the radius is double, the area becomes 4 times. So area is 4 times, and the length is double, length becomes 2L. The temperature difference is halved, so it is delta T by 2. So this 2 and 2 and 4, everything is getting cancelled out. So you are actually getting the same answer. It means that your new power will be actually equal to the same power. So there is no change, and so the answer will be B. Okay, dear students, so let us move to the next question, question number 8. Bhavi is the only student who correctly answered this question. Very good. Question number 8 out of 10. All the best. Ideally lagged bars. Now you might be confused, like what is a lagged bar? So dear students, don't get confused here. Just like the other question, that when heat is entering from this point and it is going from outside, there is no heat which is transferred from the curved area of the pipe. That kind of a rod is known as lagged rod. So don't worry about anything, just do the question. Okay, let's see what is the correct answer now. Again, only one student who has done it correctly. I think the question is the same, isn't it? They are made from the same metal. The diameter of the bar is different. One end of the bar is held at this and this for each bar. Yeah, so I won't be doing it because it is actually the same concept. You just try to apply that concept in this question. So I think Cam is the only student who did it correctly, but Anonymous is clearly leading the chart. Now let us move to next question. Question number 9 out of the total 10 questions. Yeah, this question is a bit tricky, but it is very important. Very good. 2 students are correct in this question. So this question is about the specific heat and the latent heat, and you would be concerned with how much is the energy which it is taking. So the power, like the constant rate, means that the power of the heater is the same. So more is the time, more is the energy that it is taking. So accordingly, we have the answer that the specific latent heat of vaporization is greater than the specific latent heat of fusion. Now this is vaporization, this is fusion. So clearly in vaporization it is taking a lot more heat. There is no doubt about it. Now moving next to the last question here. Very good. Bhavi has gone directly to the first rank. Let's see how it turns up for the final chart. So this is question number 10 out of all the questions. Oh. I don't know why. There are so many mistakes in this. Okay. Let's go for question number 10. This is a very conceptual question, and why I have chosen this for the test is because it uses terms which are very difficult. We are very similar looking to each other, like nature of conduction and the nature of electricity, but we have to understand the subtle thing in this. Okay, dear students, there we go. The last question, and 2 students are correct. First of all, thank you people for joining the test. There are only 3 students, those who are doing the test here, as you can see. So I'm very thankful to you people, because whenever I do this kind of a thing, I do accept that there will be more number of students, those who would be joining. So sometimes it is very disheartening that students are not joining. So it's not that very inspiring that I would be conducting more such kind of tests. So that's not good. So my request is that please you can talk to your friends and others that they should be joining, and we need more participation in these tests. Okay, students, let's now go to the scoreboard and see what is happening now. Okay, this is how the podium looks like. So point number 3 is Cam, and at second point is Bhavi, and the first point goes to the person who does not have the name, I believe. Okay, it's happening again now. The anonymous. So we were thinking from that point of view, because he was almost number 1 for all of the tests, but only in the last Bhavi came to number 1. But now again, anonymous has went to the same position back again. Okay, dear students, so this is it for today's test. So we have covered the questions also, and we did some of the solutions also, and you have even participated in the test. I hope you enjoyed. If you have some kind of feedback on this kind of test, people, please do tell me the feedback for this. Okay, what do you think about it? Whether it is good, not good, bad, we should be conducting these tests or not, more often or not, or it might be that there might be some better timings available. Please message me those kind of things. It will be important for me to understand those things. Thanks for joining this test, dear students. All the best. Bye.